So we have to solve the equation x to the power e is equals to x to the power e to the power x. So we have to solve for x to the power e is equals to e to the power x. So immediately we have in our mind that we see e is a solution because e to the power e is e to the power e, right? But how we can sure that e is the only solution, there is no other solution? What will be the formal way of writing about the solution of this problem? So let us see. It's an interesting problem asked in Mathematics Olympiad. So first of all we'll take ln x to the power e is ln e to the power x, right? So it will be e ln x is equals to x ln e. Now ln e is equals to 1, so basically we get e ln x is equals to x. Fine. Now we shall define a function fx which is e ln x minus x. First of all, look that the domain of this function is 0 infinity. So we know ln x is defined for positive real numbers and it is undefined for even 0, and ln is not defined for negative value of x. So fx is defined in positive real numbers only. Okay. Now what we will do, we will compute the derivative of f. So f inverse is f dash x will be e by x minus 1, right? So f dash x is 0 implies e by x minus 1 is equal to 0. That means x is equal to e, right? So what we get, f attains its optimum value, either supremum or infimum, at x equals to e. Okay. Now what we will try, we will try to find the signs of f dash x when x is less than e and when x is greater than e. Okay. Sign of f dash x. Okay. So when x is less than e, that is in between 0 and e, what will happen? F dash x, we see here is f dash x, and from this factor e by x minus 1, when x is less than e, it will be positive, because when x is less than e, that means this e by x is strictly greater than 1. So in that case e by x minus 1 is greater than 0. So in that case we see f dash x is positive. Similarly, for x greater than e, we see f dash x is negative. So from this also we are seeing that f e is equal to 0. Okay. So fx was this. So from this information, if we try to plot the graph of f, so suppose this is x-axis, this is y-axis, and this is origin, and this fx is defined for positive numbers, and suppose this is e. And another thing that we see is if we try to compute the limit, that is limit of fx at 0, and we will approach 0 from rights only because the function is defined for x greater than 0. So it will be limit x tends to 0 plus, and the function was e ln x minus x. Now we see when x approaches 0, ln x approaches minus infinity. So the first component will approach to minus infinity and the second component approaches to 0. So ultimately the limit will be negative. So what we see from this information, when x is approaching when x is approaching 0, fx is negative, and from 0 to e, f dash x is positive. That means fx is increasing. So it will approach to this value. Now when x is greater than e, so f dash x is negative. That means it is decreasing. So to some sense the graph of fx will be like this. So from this we can see fx is negative for all points of domain of x. Fx is negative for all points of domain of x, and it is 0 for exactly 1 point. So we see from the graph the only solution of fx is e, and we defined fx is this. So it was derived from the original equation that x to the power e is equals to e to the power x. So we can conclude that this equation x to the power e is equals to e to the power x is the only solution, and the solution is e.